Hello everyone! Today we have a truly unique device on the review table, something we've never featured on this channel before. In fact, it's the first time I've personally come across hardware quite like this. Explaining it won't be simple, but let's dive in. Today we are exploring the Luckfox Pico 86 panel. In this video we will have a look at the external features, what's inside in the main unit, discuss how to start using it, and I'll give you a sneak peek of how you can customize the demo. So, what exactly is it? At its core, this is the Linux-based computer designed for developers. It's made to be integrated into smart home systems or industrial automation solutions. The closest thing you've probably heard of is something like the Raspberry Pi. It's also a single board computer, but the approach here is a bit different. Let's take a closer look and see what this device is hiding inside its case. On the front there's a 720 by 720 IPS touch display with multi-touch support. On the side you'll find two detachable terminal blocks. One gives access to the two onboard relays. The other is for power input, anywhere between 6 to 30 volts. There is also support for RS485 communication protocol. You may have heard us mention I2C and SPI in other videos. So, how is RS485 different? RS485 is an industrial data transmission standard using twisted pair cables. It can reliably connect up to 32 devices across hundreds of meters, often using the Modbus protocol. It's commonly found in meters, controllers, sensors, smart homes and industrial systems. Compared to I2C's 1.5 meters or SPI 30 centimeters, RS485 offers much better noise immunity and distance. I2C and SPI are ideal for short internal connections between components. There is also an RJ45 port for wired Ethernet, but the version I have also supports Wi-Fi 6, which is a nice bonus. The device comes in two parts, snapped together. Let's call the screen module the main unit, and the other the auxiliary unit. In the auxiliary unit, the power section is nicely isolated. The onboard relays are rated for 220 volts AC, up to 7 amp, which opens up a lot of real-world use cases. Under the cover of the main block lies the heart of the system, the Luckfox Core 1106 module. This embedded computer includes 246 MB of RAM and 8 GB of eMMC storage. At its core is the Rockchip RV1106G3 processor, and on screen now you'll see the full list of what's integrated into it. One standout feature is the NPU, Neural Processing Unit, delivering up to 1 TOPS of AI performance, enough to handle tasks like HD video processing at 30 FPS, noise reduction in audio, and more. But to fully harness these capabilities, you'll need some solid technical skills. We'll get into that later. Nearby, you will also find the Wi-Fi 6 and Bluetooth 5 module with an IPX antenna connector. There is also configurations without the wireless module, if you don't need it. Also included inside the main unit are a speaker and a microphone, a battery slot for the real-time clock, a USB Type-C port, handy for both power and debugging via ADB UART connector, boot and reset buttons, and a 40-pin display connector. Let's snap the unit back together and power it up. So, who is this for? This platform is definitely aimed at developers with experience in embedded Linux systems. There is no ready-made user software, you'll be writing everything from scratch. If you're just starting with single-board computers, this isn't the best entry point. But if you already have experience or are curious and willing to learn, it can be an exciting challenge. For example, I've worked with the Raspberry Pi and Orange Pi, which are simpler thanks to a huge number of pre-made OS images. This device not so much, but the flexibility is huge. While preparing this review, I also stumbled upon a similar panel being used as a light controller. I didn't get to explore it fully, but managed to grab a few quick shots. Getting started, the demo firmware let you connect via Ethernet or Wi-Fi. Once connected, the main screen displays the IP address you'll need for SSH access. In the second menu, you will find the media player, volume control, a track selector, and buttons to trigger the relays. Just remember, the relays only work when powered via the auxiliary block. Let's connect to the system and take a look inside. There are two main ways to do this: via SSH over network. SSH Secure Shell is a secure protocol for accessing and managing remote systems. And second one, via USB Type-C using ADB. ADB, Android Debugging Bridge, is a command line tool for managing Android devices, and in this case, other embedded Linux systems too. To use ADB, download it from the manufacturer's website. Add its path to your system environment variables. Then open the terminal and type ADB shell. You'll be logged in as a root without no password required. If using SSH, you can also use the terminal. The default root password is Luckfox. To build your own firmware, you need to use only Ubuntu 22 LTS. I installed it in a VirtualBox VM, then downloaded the SDK from GitHub. The SDK includes everything you need to develop applications for this platform. As a reference, you can use the same demo firmware we saw earlier. It's a full example. I opened the project in Visual Studio Code, and once I told it where my SDK folder was, everything worked. The project is built on LVGL, a fantastic open source graphics library that makes graphical user interface development much easier. Light and Versatile Graphics Library is a lightweight yet powerful open source graphical user interface library for microcontrollers and low power systems. It supports various screens, TFT, e-paper, monochrome, input devices, touch, buttons, encoders, and offer a rich set of widgets, animations, themes, and multi-language support. Let me quickly show you how easy it is to modify the base firmware. We'll rename the relay buttons, test the microphone, and let's add a new button to record 5-second sound from internal microphone and play it back. Once done, we compile the project, which outputs a .bin file ready to be flashed. To transfer it to the device, there are two easy options: via SSH using SCP and via ADB using ADB push. Now we need to stop the currently running demo process and launch our new firmware. Okay, so we see a demo application in which I made some changes. I added an extra button that will help us to test internal microphone. It will record for 5 seconds and then immediately play back the recording. We can also see that the labels have been changed, so don't forget to subscribe, please. Let's start the test. Test 1 2 3 1 2 3. Test 1 2 3 1 2 3. Okay, it works. The old functionality is still preserved as well. You can create some really interesting applications by combining Linux system calls with LVGL. For example, you could play a video straight to the frame buffer. While quality won't be amazing out of the box, the chip does support DRM, so you could build the OS image with proper drivers for better video output. In the next videos, we'll explore its smaller sibling, which lets you build what might just be the most affordable high-resolution security camera on the market. And it even works entirely offline using local AI-based recognition, for example, to scare off cats. Okay, that's all for today. Thanks for watching. This is Arthur from Hobby Support. See you in the next videos.